Citizen scientists discover yellow balls in space. Presented by Science at NASA. What's green, red, and yellow all over? If you guessed the formation of massive stars as seen by NASA's Spitzer space telescope, you would be correct. Citizen scientists associated with the Milky Way project, which relies on crowdsourcing to help process scientific data, were recently scanning images from the Earth-trailing infrared telescope and stumbled upon a new class of curiosities that had gone largely unrecognized before: yellow balls of molecular matter surrounding massive newborn stars. For years, volunteers have been scanning Spitzer's images of star-forming regions, places where clouds of gas and dust are collapsing to form clusters of young stars. Searching for clues to help professional astronomers understand the process of star formation, the volunteers started chatting about the yellow balls they kept seeing in the images of our galaxy, and this brought the features to our attention, says Grace Wolf-Chase of the Adler Planetarium in Chicago. Before the yellow balls popped up, volunteers had already noticed green bubbles with red centers, populating a landscape of swirling gas and dust. These bubbles are the result of massive newborn stars blowing out cavities in their surroundings. When the volunteers started reporting that they were finding objects in the shape of yellow balls, the Spitzer researchers took note. The rounded features captured by the telescope, of course, are not actually yellow, red, or green. They just appear that way in the infrared, color-assigned images that the telescope sends to Earth. The false colors provide a way for scientists to talk about infrared wavelengths of light their eyes cannot actually see. With prompting by the volunteers, we analyzed the yellow balls and figured out that they are a new way to detect the early stages of massive star formation, says Charles Curtin of Iowa State University, Ames. The simple question of, what's that, led us to this discovery. A thorough analysis by the team led to the conclusion that the yellow balls precede the green bubbles, representing a phase of star formation that takes place before the bubbles form. Basically, if you wind the clock backwards from the bubbles, you get the yellow balls, says Curtin. Researchers think the green bubble rims are made largely of organic molecules called polycyclic aromatic hydrocarbons, or PAHs. PAHs are abundant in the dense molecular clouds where stars coalesce. Blasts of radiation and winds from newborn stars push these PAHs into spherical shells that look like green bubbles in Spitzer's images. The red cores of the green bubbles are made of warm dust that has not yet been pushed away from the windy stars. How do the yellow balls fit in? The yellow balls are a missing link, says Wolf-Chase. They represent a transition between very young embryonic stars buried in dense, dusty clouds and slightly older, newborn stars blowing the bubbles. Essentially, the yellow balls mark places where the PAHs, green, and the dust, red, have not yet separated. The superposition of green and red makes yellow. So far, the volunteers have identified more than 900 of these compact yellow features. The multitude gives researchers plenty of chances to test their hypotheses and learn more about the way stars form. Meanwhile, citizen scientists continue to scan Spitzer's images for new finds. Green bubbles, red cores, yellow balls. What's next? You could be the one who makes the next big discovery. To get involved, go to zooniverse.org and click on the Milky Way project. For updates, stay tuned to science.nasa.gov.